Hello! This video is about Sif Figs. You can see in this cartoon here, it says, my goodness, it's 12, 15, 093, lots of different numbers, time for lunch. We clearly never use that much significant figures when we tell time, and so we don't want to have too many or too few Sif Figs, otherwise we won't know. Like we just say it's noon, well, is it really noon or is it half past noon? We need to have the right amount of Sif Figs, so that's an important topic for any class in chemistry. So taking a look at these balances, you can see that the econo balance on the far left side has really only what would be called one Sif Fig. You know, the 1 or the 2, but not much else past that. The best balance you might see on the far right, this exacto balance, is much more exact, or the better word to say would be precise. Precision tells you how many decimal places you can have, or how many significant figures technically you have. So the best balance, by looking at precision, would be the one on the far right. In fact, if you look at these two right here, there's two rocks on there and they both have a mass of 0. Is it really 0? No, we just don't have enough Sif Figs to show what the mass of the actual pebble really is. So if you actually put the pebble A and B on there, you can see in the balance pro, still doesn't have enough Sif Figs until you get to the centi balance, and then you still think it's the same size until you finally get to the super balance, and you can see by Sif Figs we finally know which one is different in their mass. So Sif Figs are really important, and how many you have can tell how precise you are. Now what we do is we write our numbers like in lab reports or in any papers that are published, and so we have to be able to communicate using our numbers how many Sif Figs, or in other words, how awesome of a balance did I use in this lab. And by saying, you know, 0.02 versus 0.016, I'm communicating to the world, hey, I used a really great balance when I used the 0.016 super balance. Okay, so in order to know Sif Figs, you've got to look at the different kinds of zeros here. There are 3 different kinds of zeros. This is the way I teach Sif Figs. I use the word sandwich zeros, and if you don't like the way I do it, you can go and read the textbook rules, and they have a more scientific kind of, terminology approach. But this is my approach to it, and I like it. So the top zeros here, they're called placeholder zeros. Like these 2 zeros are here to function as creating the number 200. Without the zeros, it would just be 2. But with the zeros, it's 200. They're holding the place of the 1s in the 10s place. Same with this 0.02. Without the O, that's right here, being the placeholder 0, and this 0 too, you wouldn't see that it's actually 0.02. You would just see 0.2 maybe. And that wouldn't fully communicate things. So these are called placeholder zeros. Significant zeros are actually different. Placeholder zeros are not Sif Figs. Placeholder zeros are placeholders, and Sif Figs are significant, which makes me take a step back and say, well, what is a significant figure? A Sif Fig, exactly. A Sif Fig is all the numbers we measured that we know plus an estimated digit. So anytime we use the ruler, we know it's up to like 0.12, and then you kind of look and you're like 0.125. You make that estimated digit. A Sif Fig is all the numbers that you measure. So it'll be those exact ones plus that estimated last digit. So these placeholder zeros, like this 0 right here, would not be considered a Sif Fig. It would be considered a placeholder 0. This 0 on the 140 grams isn't a Sif Fig, it's a placeholder 0. So if I were to count how many Sif Figs is in 140, I would say there are 2 Sif Figs in 140. Taking a look at this 0.02, there's only 1 Sif Fig in this number. The other zeros are placeholder zeros. You are either a placeholder 0 or you're significant 0. You are not both at the same time. So down here, these numbers, like if you took away that 0, that last 0 that has under 9 on it, it would still be 0.02. It would still be communicating that it's the same length. But that last 0 is significant. I actually measured it, and I know using this awesome balance that it is 0.020. The estimated last digit is an O. So, the 0 really. So that's a significant 0. Same with this 177. If you took away the 0, it'd still be 177, but that last 0 tells you how precise or how great your measuring tool was. So it's a Sif Fig. My sandwich zeros are these ones at the bottom. See how they're between 2 non-zero numbers? Those are significant. If you know the 1 and you know the 2, you know the zeros in between are significant also. Here's a couple of our sandwich zeros, and these last 2 zeros are sandwich ones. These first 3 are placeholder ones. They do not count. And these last 2 are Sif Fig ones. So taking a look at it, to repeat it, any non-zero number, like 1, 2, 3, 4, 5, is a Sif Fig. Any sandwich zeros are significant, and any zeros after a decimal place and after a number is a sig fig, but our placeholders are not. So if we take a look at this number on the bottom and decide which ones are sig figs and which ones aren't, we'd start with the sig fig ones are any non-zero numbers. So there's 1, 2, 5. The 5, 2, 4, they're all sig figs. Our sandwich zeros would be these two right here. They would count. Our zeros after a decimal place and after a number, I'd call them those trailing zeros. That's these ones right here. They count. Our placeholder zeros are actually these front three. So the number of sig figs in this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sig figs. The only ones that aren't sig figs are these front three numbers. So take a look at this number 300. When I look at this, there's only one sig fig, the 3. The zeros are placeholders, so there's only one sig fig. But let's say that you actually wanted to say that it is all sig figs, so just 3 sig figs. If you want to say it's 3 sig figs, you've got to do one of two things. You can put a decimal place right here, right where I've got my dot here. If I put a decimal place there, that tells the reader that it's actually 3 sig figs, the 3, the 0, and the 0. You wouldn't have a decimal place unless you really need for the decimal place to be there, and thus it's signifying that I have measured all three numbers. Another way to do it is just to put a line directly across the top, a line across the top of any placeholder zeros that you actually need to be significant zeros. A line across the top would work. Or the third way to do it would be in scientific notation. If you said this is 3.00 times 10 to the second, that 3.00 would no longer be placeholder zeros, it's significant zeros, and that would be the third way you could do it. If I said you have 25 people, how many sig figs would you have in this? Most people might think 2, the 2 and the 5. But really, sig figs tell you how certain you are of something. How much did you measure it? How much do you know that it really is that number? If I said there's 25 people in this room, well, if you counted the number of people, you would know there's 25 people, and you would ask yourself, well, how certain are you of that? I am super certain because I counted them. That means there's infinite sig figs. Any counting numbers would be infinite sig figs. So like in an atom, if you said there's 2 protons in this atom, how certain are you that there's 2 protons? I'm infinitely certain, so infinite sig figs. So here's our recap here, significant and not significant. Here's our 300 versus 300 versus 300 versus 300. This first one has only one sig fig, and these 3 other options are 3 sig figs. Taking a look at these two numbers by the bottom, you can see that they have a different number of sig figs. So you ask yourself, were they used measuring the same piece of equipment? I would say no. All pieces of equipment would have the same number of decimal places that are significant. Like a ruler. A ruler that we use in the classroom has point something something. And anything you measure in that ruler in centimeters would be point something something. And so that's how you know that you're using the same piece of equipment, because it doesn't necessarily have the same number of sig figs, but it does have the same number of decimal places. And these two numbers here do not. Alright, that is your information for sig figs. Good luck.